A regular toilet, I think the standard is 1.6 gallons per flash.
Okay.
You can get a 0.8 as low as that, or you can have 1.4. So.
What do you estimate the cost of your house over conventional?
Conventional, I think we are right around 8% mark, more than conventional building. Because the way I think you can look at it is you're adding all this foam. You're a foam person, so you know. We're using this foam and then diverting all the costs from the HVAC system into building a thermal envelope that does not cost money to operate. So that's.
Can you talk about the permeable pavers?
Sure.
Your driveways, sidewalk?
Right. I mean, the typical driveway sidewalk is asphalt. So when it rains, it just all runs off. But there are different ways to do this. You can lay gravel and then put pavers on top. They're basically bricks or stone, depends on what it is that you use. You can even grow grass on it. And so that way, all of those things, with the tiles, what happens is when it rains, it seeps under and it just goes into the aquifer instead of running to the street. So, and we're using one of those systems. Maybe growing some grass too.
I don't know to whom I should direct this question, but when you have a southern exposure and you have large amounts of glass in order to benefit in the wintertime by solar heat, what happens at night when it's cold outside and there's no sun? How does the heat that's coming through during the daytime get retained inside during the nighttime?
David, you want to take that first?
Well, you're very careful with the selection of your windows. So you use, for southern facing windows and north facing windows, use a high solar gain glass, which allows a lot more energy to come in. Because we are really in a heating climate here. And then the heat doesn't radiate. You've got triple glazing. So you've got R7 there. So some energy is going to be going out at night, but it's a very small amount. And in your west-facing glass and your east-facing glass, where you've got direct sun coming in, and you want to keep it out in the summer, you use low E glass, which is that low E means low solar gain. So you're not getting a lot of energy through that glass. But a passive solar house, its principle is to take in as much of the sun's energy as it possibly can. And that's why you see all these big glass facades in the south. And they collect it in thermal mass, whether it's a concrete floor or heavy paving. And then it radiates back out at night. The idea is that because you can't contain it, because it's going out through leaks and whatever. Passive house, you don't need all that thermal mass to keep it because it's not going to go out. You're not losing it. Is that?
There are some passive houses that are actually incorporating the thermal mass into, for solar storage as well. Yeah. But sometimes if you're not careful, you could actually overheat the house. So.
Yeah. Actually, the thermal mass helps in our climate in the cooling in the summer.
That's right.
It's it helps a bit to have some some thermal mass in a house in our climate, but it's really not a significant factor in these houses.
As for the house you built in Bethesda, so that lot had the right direction, the front face south?
It didn't. My partner said, I've got a lot. Can we build a passive house on it? And we did we came up with the plan and we did the modeling. We said, yeah, but, and that's the beauty of this program, because we use the software to see what we were going to have to do to make this non-ideal site work. Because actually our long facade on this house is facing west, because it's got a wing on the back. It's perfectly square, but it's got a wing. So we did the modeling and figured that the best way to compensate for that was to have adjustable blinds, which you saw in one of those pictures on the west. So that when the sun hits those blinds, they go down. But you can override it as well. So we could use a little bit more glass on the south facade would have helped us a bit, but we managed to we made it without it.
Because I would think 90% of your locations are going to have a similar problem.
Yeah, or 75%, right?
Usually it's not ideal.
Or 50% anyway. But I did a thing on this house where I changed the climate number, the climate location, just one setting on the model, energy model for the house. And I said I put it in different parts of the country. And you couldn't build this house in Boston because we don't have enough south-facing glass. You could, but you would have to do a lot more with your insulation because we just don't have enough south-facing glass on it. But we could get away with that here. Now, if we built it down in the deep south, it would be very easy to build this house, and you could actually cut down on the insulation.
Right.
Because our heating load is about double our cooling load in this climate.
So in terms of passive house, a lot of times it's somewhat climate dependent. But you could do it anywhere. But for example, places in California, you could easily achieve passive house standard without really exceeding the building code. So it's kind of funny, but if you go to Minnesota, okay, you really have to have R60 walls,
Yeah.
or
It's tough.
R100 roofs. So,
What's the wall thickness on your house, Ron?
wall thickness for the SIP walls, it's 8 1/4 plus 2 inches of EPS on the outside. So we're talking about 10, a little bit more than 10.
Okay. And how about on your?
Almost exactly the same.
Same
We
thing.
used basically the same approach.
Same system.
The SIPs on the outside, the foam on the outside is to break the thermal bridging of the studs as they go. There's few framing members that are in SIP panels.
I stole that idea from you.
Thank you very much.
Okay.